Now let's see some examples where you kind of have to mentally substitute in order to factor it. So this first one, you have x squared minus 6x plus 9 minus y squared. And at first glance, well, there's no common factors, so we can't do that. It's not even the same variable. But what you might notice is that this at least can be factored. You can convince yourself that that's going to be x minus 3 squared. Now that we've recognized that, we can see, hey, this is a difference of squares. Okay, if it's hard to see for you, let's do a quick substitution. Everything I'm writing in red here is going to be optional. So we might say let a be equal to x minus 3. Then this expression is going to be a squared minus y squared. Now that's pretty easy to see difference of squares. So it's going to look like a minus y times a plus y. Now we don't want it in terms of a, so let's put it back in terms of x minus 3. So we have everywhere we see a, we're going to put x minus 3. Finally, let's get rid of these nested brackets. So this is one way that you can factor that. Let's do one more example with a slightly different substitution. So this one, 4x to the power 4 plus 12x squared plus 9. It doesn't look like a quadratic, but if you're clever about it, you can make it look like a quadratic. So let's remember that x to the power 4 is like x squared to the power of 2. Okay, so if we rewrite it like that, you'll notice that it kind of looks like a something squared plus b something plus c. At this point, you can factor it. Now, if it's hard to see, again, everything I'm writing in red here is optional and just, to help you see how to factor it. If we say z is x squared here, we can say this is 4z squared plus 12z plus 9. That is something that we can factor pretty easily. So in fact, this one is a perfect square as well. That's not always the case, but it is in this case. It's going to be 2z plus 3 all squared. Now we're going to put that back in. So it's going to be 2x squared plus 3 all squared, and that's your final answer.